We're asked to find the particular solution to the initial value problem y double prime plus 5, y prime plus 6, y equals 0, with initial conditions y of 0 equals 2, and y prime of 0 equals 3. This is a linear, homogeneous, second-order differential equation with constant coefficients. We'll go through it step by step. Here's the plan. First, form the characteristic equation. Second, solve the characteristic equation. Third, write the general solution. Fourth, use the initial conditions. Fifth, solve the system of equations for the constants. And sixth, write the particular solution. We assume a solution of the form y equals e to the rx. Substituting this into the differential equation gives us the characteristic or auxiliary equation, r squared plus 5, r plus 6 equals 0. We then factor this quadratic equation into r plus 2 times r plus 3 equals 0. This gives us two roots, r sub 1 equals negative 2, and r sub 2 equals negative 3. Since we have two distinct real roots, the general solution is of the form y of x equals c sub 1 e to the r sub 1x plus c sub 2 e to the r sub 2x. Substituting the roots we found, we get y of x equals c sub 1 e to the negative 2x plus c sub 2 e to the negative 3x, where c sub 1 and c sub 2 are arbitrary constants. Now, we need to use the given initial conditions to find the constants. First, we apply y of 0 equals 2. Substituting x equals 0, and y equals 2 into our general solution, we get 2 equals c sub 1 e to the 0 plus c sub 2 e to the 0. Since anything to the power of 0 is 1, this simplifies to c sub 1 plus c sub 2 equals 2. We label this equation 1. Next, we need the derivative of y of x. Taking the derivative, we get y prime of x equals negative 2c sub 1 e to the negative 2x minus 3c sub 2 e to the negative 3x. Now we apply y prime of 0 equals 3, substituting x equals 0, and y prime equals 3. Into the derivative, we get 3 equals negative 2c sub 1 e to the 0 minus 3c sub 2 e to the 0. This simplifies to negative 2c sub 1 minus 3c sub 2 equals 3, and we label this equation 2. Now, we have a system of two equations with two unknowns. Equation 1, c sub 1 plus c sub 2 equals 2. Equation 2, negative 2c sub 1 minus 3c sub 2 equals 3. From equation 1, we can express c sub 1 as 2 minus c sub 2. We substitute this into equation 2 to get negative 2 times the quantity 2 minus c sub 2 minus 3c sub 2 equals 3. Expanding, we have negative 4 plus 2c sub 2 minus 3c sub 2 equals 3. Combining like terms, negative 4 minus c sub 2 equals 3. Adding 4 to both sides, negative c sub 2 equals 7. Multiplying by negative 1, c sub 2 equals negative 7. Now, we substitute c sub 2 equals negative 7 back into the equation c1 equals 2 minus c sub 2. This gives us c sub 1 equals 2 minus negative 7, which simplifies to c sub 1 equals 9. Finally, we substitute the values of c sub 1 and c sub 2 back into the general solution. We had y of x equals c sub 1 e to the negative 2x plus c sub 2 e to the negative 3x. Substituting c sub 1 equals 9 and c sub 2 equals negative 7 gives us y equals 9 e to the negative 2x minus 7 e to the negative 3x. This is the particular solution to the initial value problem.